This presentation is going to be a two-part message. The first part is I'm going to try to set the framework for life cycle analysis and the other presentations that are going to follow. One thing that I've certainly found about this topic is there's a lot of opinions and different perspectives on what life cycle analysis means. So I think a little bit of a primer on just where is the history of LCA and where are we specifically with practice in the U.S., which is what most of this talk is today, I think is worthwhile. The second part is I'm going to give a case study of two different projects in the U.S. They're MKA projects where we've used a new piece of software that's out, Tally. It's a module within Revit to let you look at life cycle impacts of your buildings, and we've done a test case of these two projects, and I'll walk you through those details. And I'll talk a little bit more about Tally as we go. Certainly, it is a quickly evolving field, and one I'm excited to see the traction that is happening here. So this is my one promo slide on Magnusson Klemencic, and this is just highlighting some of the projects that we're working on in the area. MKA, as Ron had mentioned, we are a structural and civil engineering practice. We focus on design leadership, innovation, and value-driven optimization. And that word optimization is the one I really want to focus in on here, because I think that's really the structural engineer's role in sustainability. I think that's where LCA can come in as a tool to tell our LCA story. And frankly, it's what really drew me into life cycle analysis to begin with, is to try to make the structural engineer more relevant in the sustainability debate, in the sustainability conversations. And that's really about optimization, doing less with more of the materials that we have, and creating lower carbon footprint buildings. So what gets measured gets targeted for improvement. I think this is the real motivation and the power behind life cycle analysis. What we do, we are a resource-intensive business, or design profession. Concrete, rebar, steel, timber, all of these products have environmental impacts. But if we take the mindset of these and we don't think that they're going to go away, and I don't think that they are, if we simply treat them as precious resources that need to be used wisely to optimize, to manage, we can do beautiful things with them. And frankly, for what I have seen in life cycle analysis to date, the most progress that is happening isn't when LCA is being used as a wedge issue to compare wood versus steel versus concrete. Frankly, it's when you create inner competition within the same materials. It's very hard to assess land use issues and road building of timber construction with energy impacts, say in the steel industry. You're comparing apples and oranges, and frankly today I'm not sure we have the tools or the understanding quite yet to how to measure between the two. But when you look at it from the lens of within each particular material and using these materials for what they are best at, I think that's where there's progress to actually be made, and I think that's actually where the best hope is for LCA, certainly in the near term. So a little bit of history on LCA. It really started in its current version in the 1990s in Europe, when ISO created some standards to measure the life cycle impacts of buildings. And I still think, frankly, Europe is a leader today in LCA modeling. But I think that ISO standard and much of what is happening in the U.S. is created the template by which U.S. practice is currently happening. So in the USA today, groups like ASTM, UL, the International Building Code, LEED, are all starting to bring in material resource credits and life cycle analysis into their activities to make them relevant in this debate. Groups like Architecture 2030, their Material Products Challenge, and the Carbon Leadership Forum are a couple of groups that are certainly help defining standards and mechanisms by which this LCA modeling is taking place. So a couple of quick acronyms in LCA. Product Category Rules. This is an industry. Typically, PCR is developed but within industries, so whether it's the concrete or the steel or the timber, they, within that industry, create their own set of boundary conditions by which environmental impacts are going to get measured. And PCRs typically are, there's third-party involvement in their, and a large stakeholder constituency to give input into what should be in a PCR. But the real purpose of the PCR is to then create, and we're missing some images here below it, but something called an environmental product declaration, so an EPD. This is really where the data exists, that if you're trying to collect data on vendor-specific information for life cycle analysis. Oh, here we go. So some of the different EPDs that are currently available in the US today. EPDs generally have to be third-party verified in order to make ISO standards, and so there's a transparency to what is going on. These are a couple of the groups that are currently providing some of the different EPDs, and that list is quickly growing. And so that's kind of the mechanism and the process, but we really have to ask ourselves, we're always looking at, why bother? Is it worth the effort? And we could get into the long conversation of global warming and just being responsible stewards, which I think is in many cases, almost a foregone conclusion. But the raw economics of green building design is a rapidly growing field. And even more so outside of the residential market in the US. I think currently today it's approaching 50% of the market in the built market is considered green in some way. And so where LCA really comes to play is I think we have to honestly ask ourselves and answer the question, are we just greenwashing? I don't think I am telling anyone in this room something to say that there isn't a lot of greenwashing that goes on, things that get pitched as a sustainability idea that really probably aren't really making much of a difference. And that trust, that kind of credibility argument of what we are doing, I think this is where LCA comes in. It is the tool by which we have a metric to measure. We have a metric to create standardization for defining that trust. And it's a very open sourced element where then people have a metric by which to look at what we're doing. So if I look just in the US as an example, historical marketing, the message was, just trust us. Well, we're going to take care of you. But abuse of the public trust, frankly, leads to suspicion, leads to people not believing what's happening. And once you've created that distrust, it's very hard to get it back. And so, I'm using the tobacco industry as an example right here. But when you lose that trust, what that quickly leads to is government regulation and rules of enforcement being put in, sometimes effectively, sometimes not, that force us to do certain mechanisms of reporting standards or, in the case of tobacco, certain disclosures. Now, EPDs, which I mentioned, really it's a disclosure. It's kind of like the nutrition label on a box of cereal. It's the numbers, and we live in a data age, so everyone's just rampant to get numbers. And so I think EPDs help provide that information and data. LEED is, like I said, is certainly getting into the act here. LEED version 4, which has just recently come out. Most projects in the U.S. are not following LEED version 4, but that adoption is the next generation of buildings that are to come. It has 13 credits, specifically tied to material impacts. And so this is certainly the first place that I think LCA in the U.S. is really starting to get some teeth and have a quantifiable reason for being. It's either coming through legislation of one kind, whether it's carbon credits or carbon taxes that are being talked about in some locations, or like I say in this case, there's 13 points that will be in LEED around this topic in LEED version 4. Frankly, I think there's a lot of work still to go here. I think this document is far from perfect, and I think it's too complicated, but it's the step, and it's the evolution that is coming. Industry response, they're all on the game in some way, and whether, like I said, the timber, the steel, the concrete industry, each of them have their initiatives that they have launched to try to get on top of life cycle analysis. Certainly within CTBUH, the efforts of ArcelorMittal are significant and notable towards looking at the steel industry in tall buildings and LCA. But I think the real message here is you either need to be part of the process or you're going to get steamrolled by it because it is a freight train that is coming down the tracks. And I'll just use concrete as an example. In the ideal concrete world, where they would like to see as an outcome of LCAs, instead of us in our specifications telling the contractor how to make their mix. Thou shalt use a minimum of 50% fly ash or certain cement replacements. Let's go to performance specification. Maybe it's something like thou shalt have a maximum of 350 kg per CO2 in the mix design. You know, frankly, as a structural engineer, I'd like to get out of the telling the material supplier how to make their product. I'm not the expert on that. They are. If we can simply set the benchmark of what we're really after, maybe it's the case of a lower carbon footprint, leave it to their creativity and market abilities and technical abilities to help to produce mixes to do that. It may not always be simply by cement replacement, by fly ash or another mix. There's a lot of other strategies that can be out there. So another real question we need to ask ourselves in LCA is, when should the impacts be measured? Many LCA studies today, it's a one-time shot, and we look at a number, but you know that number is just a point in time. And if it's a look backwards after a project is done, we really didn't inform the design process to make a difference. And if you do it too early in the design process, the information will probably be on industry averages, but it may not really totally be meaningful in where we're going. So I think this is certainly an issue of further growth. Myself, I really think what we're really after is creating triple bottom line buying decisions, but I think it requires a two-step process. I think at LCA should be a look during the design process and then another look again during the buyout process during construction. And I think both steps have a very critical fundamental role in trying to reduce lower carbon buildings. So phase one in design, as I mentioned, frankly, I think around the design development level is a good time when we have a definition of what a project is. We have a good handle on what the consumptive materials would probably be going into the building. Certainly, if we have a Revit model, it makes it a whole lot easier. And it also gives us the benchmark, whereas engineers, we can then look to optimize. And as we refine and look at different permutations of our design choices, we may be able to reduce the carbon footprint of a building by 50% just through engineering optimization and our choices of what we do in design. Now, this is where the program Tally comes in, and I'm quite excited about this for a couple of reasons. It's the first time I've seen a tool that's a third-party tool out there where we can use the Revit model that we're already building during design. And Tally is a hard coding in of the Gabi database, which comes from PE International, into Revit. And so you have industry average data that you can plug in, and you can quickly start to assess the environmental impacts of your system choices using that industry average data. And like I said, the Gabi database nationally and internationally, I think, is one of the best that is currently out there. So having that hard coded in starts to give us a tool we can use during design to make it relevant, to frankly make the process easy enough that we might actually choose to use it during design. I also like Tally. MKA before this existed, we had our own internal embodied carbon tool that we tried to use, but we were running against the problem because it was ours internally. It wasn't necessarily open source, validated within LEED, so we couldn't really use it for LEED purposes. What I like about Tally is it's a third-party vendor-supplied product that is endorsed by LEED, and so when looking at LEED credits, it's there for its use. Now, information that might come out of this, it helps you look at the supply chain of materials. This is looking at steel in the U.S. industry, and the green bars there is the material impacts due to electricity, due to energy. So the message there on steel, frankly, it's about the energy supply at the mill. That's the greatest environmental impact, whether it's rebar or rolled steel shapes, for most steel products in the U.S. If you were going to bring this to China, where might this inform a buying decision? Given that the Three Gorges Dam is already there, and we're not talking about environmental impacts of the building of the dam, you know what? I'm guessing a steel plant directly downstream from the Three Gorges Dam using hydropower probably has a significantly different environmental footprint than, say, a steel plant down by Guangzhou that is run by coal-fired generation. Simply by asking the question, you may be able to get a very different footprint to your materials just by looking at the material supply chain. Output that comes from Tally, this is direct out of Tally input. It gives you a variety of different categories whether we're looking at global warming, which is really embodied carbon, eutrophication, ozone depletion, acidification. Those are all the topics that LEED is focusing on in their material resource credit. So you're getting direct raw data out from that. And then I mentioned construction. I think doing that model during design is great, but it is really only based on industry average information. The best way for us to affect change is actually at the point of the buying decision and to bring environmental impacts into that buying decision. And so maybe for a material like, say, concrete, where if the costs are the same between two different suppliers, but one has a much lower embodied carbon footprint on the material, that should be the one that leads the day. And I think that's one of the values of trying to use this LCA tool is, and frankly EPDs, which I'm talking about, if the market pressures are there to request those, you can start to use that in your process. You get that in, like I said, you can get the vendor-specific information. So quickly, case study, the first project I'm going to talk about, 201 Folsom or Lumina, it's the two towers on the right there. This is a two-phase project. Tishman is the developer of this. Bob, I think, did the 300 Spear version of this in 2008, the first two towers, and we're now building the second two. And so this project is currently under construction. Now, TALI didn't exist, and EPDs didn't exist when this project started, so that this is an optimized design for value-based design. There's fly ash in the mixes, but it wasn't done for low carbon specific purposes, but we did it as a look-back process. I pulled up the Revit model, and like I said, we pulled up the Revit model. We've looked specifically at the structural frame, so I'm looking at the concrete, rebar, steel, formwork, post-tensioning to do this evaluation. So I'm really just looking at the structural components of the building. Here's just a picture of the block going up. It's the two tall performance-based designed residential towers at 40 stories, and then there's two shorter 8-story towers that fill out the block. There's a lot of steel. We're in a high seismic zone, and so the densities, obviously, at the lower levels, especially in the mat and the walls, are significant. And here you can see the tower is going up. So a quick picture here. This is a pie chart of the embodied carbon footprint of Lumina. And without even getting into total kg numbers, just looking at the pie chart, a couple of things to pay attention to. The floor system of concrete and rebar for what's this all-concrete tower is 45% of the equation. Now, we've known that because that's how you optimize buildings. It's about the floor plates. Whether it's a tall building or a short building, you always start with the floor plates. But this gives us a quick tool when you want to make the biggest difference of optimization. You know what? The first place to go look is the floor systems. What can you do on the floor systems to optimize and reduce the volumes? And what we found on this, taking the industry average information from TALI, and in this case, we were able to get EPDs from the concrete suppliers for each of the mixed designs that went on the project. We actually found an amazingly close correlation. So this actually, to me, was validation that, hey, TALI's pretty darn good for what's happening in the San Francisco market. This project actually helped stir on getting EPDs now to the two biggest suppliers in the San Francisco market, between Central and Cemex. So now on go-forward projects, we can actually, if those are the two main suppliers going to San Francisco, we can actually ask this question and start bringing this data into the conversation. And so San Francisco is first in the U.S. for doing this, but I think this is a quickly evolving trend that is coming. So then quickly, I'm gonna, so we don't run out of time here, second case study. This is a project in Seattle. I like the number 2030 from the 2030 Product Challenge. So 2030 8th Avenue, it's another 40-story apartment project. This is GID Development is the developer. You can just, it's hard to see, but down in the bottom center of the corner, as you see the tower coming up. Seattle right now has a big resurgence of office development going as well. Amazon is building a corporate headquarters, and you can see a couple of other full city blocks underway directly to the right. Again, it's a performance-based design, ductily detailed core, so some fairly heavy reinforcement in the core as we're going up. Yeah, post-tension concrete flat plates, no beams, perimeter columns. So, to describe the building, it's actually relatively simple above grade. There's really three components. There's a wall, there's a plate, and there's columns. And, okay. And I'm done. Well, I'll just talk about the rest of the results then from there. What you're not seeing here, though, is if you saw the pictures from the Lumina project in San Francisco, actually on this project there was a significant difference in the embodied carbon of the concrete and the rebar between tally and what was actually built. And part of it is regional. In Seattle, we have a great aggregate supply, and so the mixes can be tuned up a little bit more. Part of it has to do with, frankly, quality control and consistency of the batch plants that we're supplying the mix. The rebar in Seattle also has some that went into that 2030 project, has some unique characteristics. As I mentioned, Nucor has a plant in Seattle that is all hydropower driven. And so rebar, 90% recycled content, all hydropower, coming directly from inside Seattle, is probably some of the lowest carbon footprint steel that you can get on a project. And so in that case, Tally actually significantly overshot estimating what the carbon footprint was. Now, the punchline in Seattle, and I'll use that rebar as an example, Nucor is one supplier that has a very aggressive process, and their environmental footprint is very low. Their competitors in town selling a commodity material at the same price, most of it is shipped in and it's made elsewhere in the country in locations that are coal-fired generation with a much higher carbon footprint. Simply by asking the question, you can greatly vary the carbon footprint of your building without even changing the design. And so that's one of my biggest reasons to say you really got to do it as a two-part process, and it really has to become part of our buying decision. And we're back. Here we go. So there you go. That's of the whole project. And then this is, in fact, looking at the high-strength concrete mixes between those two towers, or between Tally and what we got for project-specific EPDs on that particular project. So there is a variation. So just in conclusion, just to bring it back around, I think life cycle analysis is coming. I think especially in the U.S. with LEED version 4, it's getting a lot of momentum. I think it behooves us to continue pushing for standardizations of how this process goes so we actually can compare apples to apples and not necessarily apples to oranges. And beyond that, I'll save the rest for if you have questions when we get up in our question and answer session. But please ask if you have any. Thanks.